Yeah, this is part 2 of Unit 6A. We are looking at this problem right here, the margin of victory in Super Bowls from 2003 to 2017. Here's all of our data set. In the last video, we found the mean and the median margin of victory. So the mean was 9.93, the median was 6. Now you want to identify the outlier. In this case, we're just going to identify one outlier in the data and see what happens if we eliminate that outlier. So here's our data right here, and the 35-point victory was an outlier. So I'm going to delete that, and now I'm going to go again back up to Stat, Summary Stat by column, click var1, and compute. And notice now that our median changed by a single point, and our mean dropped down from 8.9 to 8.14, so it dropped down by about 0.8, and so it eliminating that 35 did bring down that mean, and again we can see just how much that one value can tug down on our mean. So in this case, in part B, the mean was 8.1. The median did happen to drop, so that middle value dropped by 1 as well. I said 0.8, 1 and 0.8. So you can see that it had a pretty drastic effect on the mean when we pulled out that 35. So when you have outliers, they tend to pull the mean to the left or to the right, and it actually does what we call a skew to our data. We're going to talk next about shapes of data. So when we look at the shapes of data, it helps give us a kind of a complete idea of what's going on. And so in this case, we're going to be interested in the general shape. It's easier to focus on smooth curves that fit data rather than dealing with the actual data that can be kind of all over the place. So we're going to look at 3 different examples that approximate data distributions. 2 of them are shown as histograms, and 1 is shown as a line chart, but each of them we're going to draw a smooth curve to give us a good approximation of that original distribution. And so that's what this is right here. So you can see, the histograms lining up. But what we want to do is we want to say, okay, that's what the histogram looks like, but this little kind of bell-shaped curve right here is the general pattern that this distribution follows. Or in this one, we have 2 peaks, and then on the line chart, we again have kind of this almost looks like a bell curve. We're going to talk about the normal distribution. So when we look at these, when there's 1 peak, they're called single peak or unimodal. And then if there are 2 modes, in this case, in example B, the second peak is lower than the first, but it's still a peak. We call that bimodal because there are 2 peaks. And then there's some distributions that don't have a mode, and those are called uniform distributions. Or sometimes there are some that have more than 2. But in all our cases, we're mainly going to be looking at when there's a single mode, when we have 1 single peak. But again, the lines here that I've highlighted, those are just going to be the way we describe the general shape. To see kind of a smooth curve to give us a better idea of what we're looking at. Okay, now a couple other concepts or vocabulary words we're going to be looking at when we try to describe the distributions is symmetry, or sometimes the lack thereof. And things are symmetric if the left half is like a mirror image of the right half. So if you are able to find this line of symmetry where you can kind of imagine just cutting down the middle and you see exactly the same thing on the left and right, if you were just to fold over that dotted line, is one way I like to think of it. If you can do that, then the graph is what we call symmetric. So all of these graphs here, A, B, and C, are symmetric because you can see if you cut down those lines and kind of just imagine or just fold across those lines, they should match up perfectly. Okay. However, if a distribution is not symmetric, then we have values that tend to spread it out to one side or to the other. And those are what our outliers do. And in this case, we say that it is a skewed distribution. So this figure down below here that we've got a left skewed, a right skewed, and then you can see your general symmetric. And so in our first one, if we have outliers to the left here, so they're lower than the majority, it pulls this distribution out to the left. And so what happens is we have one mode that tends to occur, and then the median followed by the mean. So the outliers will always pull the mean towards what we call this tail or this end. So the mean is going to be less than the median when we get pulled to the left. When we're right skewed, the opposite is true. The outliers pull us to the right, so they're going to pull the mean farther to the right, so the mean is going to be greater than the median. And again, the mode tends to be where we peak out here. So these each have one peak. And then if you're symmetric, in a symmetric distribution, your mean, median, and mode tend to line up generally in the same spot. So again, that's left skewed, right skewed, and symmetric. So one way to remember the left skewed versus right skewed is, where are the outliers? Are the outliers lower or further to the left? If they are, then that's left skewed. If right skewed is when those outliers are much higher and they're pulling you to the right. Okay. So there's just some general definitions of symmetry and skewness, and you can look at that. So a third way we describe distributions is based off of what we call variation. Now we're going to talk about variation very generally here, but variation is just a measure of spread. How spread out is our data? So if the data tends to cluster or get really close to together, a lot of things are really close, then we have what we call low variation. We get a very sharp peak like this. So we get a single peak. They're all clustered really close together. As you start to spread those out away from the mean, the further away they get, we start to get, in this case, so a single peak, we get moderate variation. They're a little bit more spread out. The peak's not as dramatic. It's not as high. And then when you spread them out even further, you can get still a peak, but it's not very dramatic at all. That's a high variation. So depending on how spread out our data points are, it tells us whether we have a low variation, moderate variation, or high. So in this lesson, we're going to just be looking generally at low, moderate, and high. We're just going to make some broad statements about that. But in the next lesson, we're going to talk more about specifics of standard deviation and the variance as far as how we measure that spread. Okay, I'm just checking my time here. So in this one, this problem right here, we are going to look at the annual snowfall amount in 50 randomly selected American cities. How many peaks we would expect there to be is part A. So if we look at 50 cities, how many peaks would we expect there to be? Okay, in this case, it's pretty safe to say that we would generally expect one single peak where you'd have, kind of the majority of the cities are going to be in a single range or area. They're going to be pretty tight knit together. And so if I were to draw kind of a picture of what I think this would look like, so if we are looking at our distribution, we would have, I think it's going to be right skewed, where we'd have a lot of cities would fall into a category, and then it would start to tail off, and there would definitely be outliers to the right. There's definitely going to be some places that have a lot of snowfall, and so those places are going to be, those data points are going to be pulling us way out to the right. But we also have a minimum. I mean, there's potentially a place gets no snow, so we know we have a minimum. So that's based off of that, I know that this is going to be skewed right, because the left is kind of stuck. It can only go so low. The majority are going to be around a certain range. We don't know exactly what that range is, but the majority are going to cluster around a certain range. But there will be places that pull this further and further to the right. So in this case, we would say that this would be most likely follow a right skewed distribution. Again, we're just getting very general here. And so I guess that would be part C right there. It's right skewed, because again, there's that lower limit, but the higher limits they're just unknown. We don't know what they are, but we do know that those higher values, snowfall values, are going to pull us. Now, how much variation would we expect? I think we'd expect a large variation if you grab 50 random states. If one of those or cities, excuse me, if one of those is Phoenix, you might get a trace every few years. If you grab another one like Boston tends to get a lot more snowfall, so that could skew the data. If you get a like Salt Lake City, it might help skew this a little bit. And there's going to be a lot of places that get an okay amount and tend to cluster around that one peak. So that's just a general broad way of looking at that kind of information. So we'll look at one more example and then what's called weighted mean in our last video.